Look around you. Everything is in a state of constant flux, a relentless dance of creation and decay. From the mightiest mountains to the smallest leaf, nothing remains untouched by the passage of time. This universal process often appears as a slow, inevitable decline. But what if this decay, this constant transformation, isn't a nightmare? What if it is, in fact, the very engine that drives our world, shaping everything we know and experience? At the heart of this ceaseless change lies a fundamental chemical reaction: oxidation. Simply put, oxidation is the loss of electrons from an atom or molecule. It's an invisible transfer of energy, a silent exchange that redefines matter. When a substance loses electrons, we say it has been oxidized. This process rarely happens in isolation. It requires a partner to accept those electrons. Often that partner is oxygen, a voracious electron stealer. Oxygen's insatiable appetite for electrons makes it a key player in countless transformations. Its interaction fundamentally alters the nature of the substance it encounters, leading to profound changes. Consider a freshly sliced apple. Within minutes, its pristine white flesh begins to turn brown. This isn't magic, it's oxidation at work, as enzymes in the apple react with oxygen in the air. Perhaps the most iconic example is rust. Iron atoms exposed to oxygen and moisture willingly give up their electrons. This forms iron oxide, a brittle reddish-brown compound we call rust. Rust is a slow, relentless process. It silently weakens bridges, corrodes car bodies and undermines structures, demonstrating oxidation's destructive power. Yet, oxidation is far more than just decay. It is the engine for an astonishing array of processes, both destructive and life-sustaining. Think of the roaring inferno of a fire. That too is rapid oxidation, releasing immense energy. The power that lights our homes and runs our devices often comes from batteries discharging. This controlled release of energy is another form of oxidation, a precise electron transfer. Even the sweetening of fruit as it ripens involves oxidative processes. Nature orchestrates these reactions to transform starches into sugars, making the fruit palatable. Crucially, oxidation fuels life itself. Our bodies constantly break down food for energy, a process known as cellular respiration. This is a highly controlled form of oxidation. Glucose, our primary fuel, is slowly oxidized with oxygen, releasing the energy stored in its chemical bonds. This energy powers every heartbeat, every thought, every movement. Combustion, like fire, is a rapid, uncontrolled oxidation that releases energy as heat and light. It's a dramatic, explosive version of the same fundamental electron exchange. Cellular respiration and combustion are two sides of the same coin. One is a carefully regulated biological process, the other a swift, powerful release. Both are driven by oxidation. Oxidation is ubiquitous, woven into the fabric of our daily lives. It affects the cars we drive, the bridges we cross, and the food we eat. Its presence is inescapable. Understanding oxidation is vital for preserving our resources. Antioxidants, for instance, are compounds that prevent or slow down oxidative damage in food, extending its shelf life. This knowledge is crucial for food science, infrastructure engineering, and even understanding the aging process. It empowers us to mitigate its destructive aspects. Scientists and engineers are constantly developing new materials and techniques to combat unwanted oxidation. They strive to create more durable structures and efficient systems. Practical solutions abound, from rust-resistant coatings that protect metal to advanced battery technologies that harness oxidation more effectively. We are learning to control this powerful force. But oxidation's influence extends far beyond our planet. It has a cosmic connection, linked to the very creation of elements in the universe. In the hearts of dying stars, nuclear fusion, a process of immense energy release, can be seen as a form of cosmic oxidation. Lighter elements fuse, giving up particles and energy, forging heavier elements. Oxygen, the primary electron acceptor in so many earthly reactions, is one of the most abundant elements in the universe. Its prevalence is a testament to its universal power. This fundamental process, this exchange of electrons, has shaped the cosmos itself. It is a universal power, driving stellar evolution and the formation of all matter. Even the slow decay of our own bodies, the process of aging, is intimately tied to oxidation. It's a gradual, relentless process that affects every cell. Free radicals, highly reactive molecules, are byproducts of normal metabolic oxidation. These can damage cells, contributing to disease and the visible signs of aging. Oxidation, then, is a force of profound duality. It is the rust that corrodes, the fire that consumes, and the decay that marks the passage of time. Yet it is also the spark of life, the energy that sustains us, and the cosmic forge that creates the very elements of our existence. It is both destroyer and creator. This constant flux, this ceaseless change, is not merely a scientific phenomenon. It is a profound truth about the universe, a reminder that everything is interconnected, constantly transforming, forever in motion.